Hello friends, welcome back to my channel Maths by Samit Deshmukh. In this video, we are solving question number 8 of exercise 1.2. In this exercise, we are solving the example to find out derivative of inverse trigonometric function. Up to last video, we have completed first 7 questions. Now let us start the question number 8. So if you are new on my channel, subscribe the channel and hit the bell icon so that you will get the notification of every newly uploaded video. So observe, in the question number 8, whatever maybe the function is given to us, we have to find out derivative of that function. So observe, what is the given function? Y is equal to sine inverse of 4 sin x plus 5 cos x upon under root 41. So if here sine inverse appears, means in the given function sine inverse is there. So our aim is to convert this expression in terms of sine so that sine inverse and sine will get cancelled according to one property of inverse trigonometric function. So now we are trying to convert this expression in terms of sine. So let us see how to convert this expression in terms of sine. Whatever may be the method we are using in this example, exactly same method we are applying in remaining example from this question number 8. So here keep this sine inverse as it is. First we are simplifying this given function, and after simplifying we will find out its derivative. So here sin x, keep it as it is, whatever may be the numerical value. What is numerical value? 4 upon under root 14. So write down this 4 upon under root 14. Just simply I am dividing to both the terms separately by this denominator. Here what is the trigonometric function? Cos x. And what is numerical value? 5 upon under root 41. Means simply what we are doing here, we are dividing to both the terms separately by under root 41. So in all these examples we are using exactly same method. Here whatever the numbers are given to us, let us try to find out sum of their square. So observe here what result we will get. So here we can say that 4 upon under root 41 whole bracket square plus 5 upon under root 41 whole bracket square. Let us check what value we are getting. Means we are taking sum of square of these two numbers. What is square of 4? 16. Square of under root 41 is 41. Here square of 5 will be equal to 25, and square of under root 41 will be equal to 41. So if you will observe both the term, denominators are same, so that's why we are taking addition of numerator. 16 plus 25 is 41, divided by 41 is equal to what? 1. Means what we have proved here, that sum of square of these two number is equal to 1. Even we know that sum of square of sine and cos is also equals to 1, and here this number satisfies the identity. Which identity? That sine square theta plus cos square theta is equal to 1. Means if I am denoting this number by sine and this number by cos, so as the sum of square of these two number is also 1 and sum of square of sine and cos is also equals to 1, that's why we are able to denote this number by sine and this by cos, or denote this number by cos and this number by sine. Hope you have got it. Why we are able to consider this as sine and this as cos? Because sum of square of these two number is 1, and even the sum of square of sine and cos is also equals to what? 1. That's why we are denoting this number. So let us denote this number by what? Cos. Why we are denoting it by cos? That also we will discuss. So let cos alpha is equal to 4 upon under root 41, and this number I am denoting by sine. Sine alpha is equal to 5 upon under root 41. We have two choices here. If either denote this by cos, then this by sine. Or if I am denoting first number by sine, then denote second number by cos. But what is our aim here? Here we have to convert this expression in terms of sine. Why we have to convert this expression in terms of sine? Because here sine inverse is there, and we are trying to arrange the term in the form of property. Which property? Sine inverse of sine theta. So that sine inverse and sine will get what? Cancel. and to convert it in terms of sine, this term should be cos. Why this term should be cos? अगर ये cos है तो ये sin हो जाएगा, तो एक्सप्रेशन कौन से फॉर्म में आएगा? sin a into cos b plus cos a into sin b is sin a plus b, isn't it? And if we are able to convert it in terms of sin a plus b, sin inverse and sin will get cancel. तो हमें sin के फॉर्म में लाना है, इसलिए हमने इसे किससे डिनोट किया है? cos, because our formula of sin a plus b is sin a into cos b, तो ये cos होना चाहिए, प्लस cos a into sin b, इसलिए हमने इसे sin से डिनोट किया, just to convert this expression in terms of what? Sin. So therefore y will become, or before that, here we can observe that if we are taking division of sin and cos, so tan alpha will be equals to, what is tan alpha? Sin alpha upon cos alpha. Sin alpha upon cos alpha will be equals to, what is sin alpha? 4 upon under root 41, and cos alpha is 4 upon under root 41. So here under root 41 will get cancelled. What will get? 5 by 4. So this implies that alpha is equal to, take tan on this side, so it will become tan inverse of 5 by 4. And value of tan inverse of 5 by 4 means value of tan alpha is value of alpha is tan inverse of 5 by 4, means we can conclude that value of alpha is constant. So that is alpha is constant. Now let us substitute all these values in this expression. So therefore y will become, so what is y? Y is equal to sin inverse of sin x into 4 upon under root 41, but 4 upon under root 41 is nothing but cos alpha, plus cos x, keep it as it is, cos x as it is, and 5 upon under root 41 is nothing but sin alpha. So which is equal to sin inverse of sin a into cos b plus cos a into sin b is the value of sin a plus b. A is x and b is what? Alpha. Now here we have converted this expression in terms of sin. Now according to our property, sin inverse and sin will get cancelled. What we are getting here? X plus alpha. This is the value of y. Now we are differentiating it with respect to x. So derivative of y with respect to x is dy upon dx. On this side derivative of x is 1 and derivative of alpha will be equal to 0. Why derivative of alpha will be equals to 0? Because if you observe the value of alpha here, x does not appears, means variable does not appears, and since variable does not appears means we can conclude that alpha is what? Constant. And we know that if alpha is constant, then its derivative will be equal to 0, because our standard formula says that derivative of constant term is what? 0. So this implies that dy upon dx will be equals to 1. So same method we are applying in remaining all example from this question number 8. Now see the example number 2. In this example, what is the given function? Y is equal to cos inverse of root 3 cos x minus sin x upon 2. Here also we are trying to convert this expression in terms of cos, so that cos and cos inverse will get cancelled, and later on we will find out the derivative of what? Simplified form, means it becomes very easy to find out the differentiation. So let us try to convert this expression in terms of cos. So to convert it in terms of cos, same method we are applying which we have applied in the last example. So cos x, keep it as it is. What is the numerical value here? Root 3 by 2. So into root 3 by 2 minus sin x, keep it as it is, and here nothing is there, means 1 is there, 1 by 2. So numerical value is 1 by 2 here, isn't it? So now our aim is to convert it in terms of cos. And what is the formula of cos a plus b or cos a minus b? Cos a into cos b. And here either plus or minus is there, sin a into sin b. Means to convert it into cos, this number we have to denote it by what? Cos. And this number here we have to denote it by what? Sin. So that it will be get converted either in the form of cos a plus b or cos a minus b. What is our formula? Cos a into cos b. Either here plus or minus is there, adjacent here minus is there, देन साइन ए इंटू साइन बी. इस फॉर्म में अगर एक्सप्रेशन आता है तो हम उसे कॉस में कन्वर्ट कर पाएंगे. तो इसका मतलब हमें रूट 3/2 को कॉस में कन्वर्ट करना है, सो दैट कॉस ए इंटू व्हाट विल गेट कॉस ए इंटू कॉस बी. अभी कोइंसिडेंटली क्या हुआ है कि रूट 3/2 हमें पता है किसकी वैल्यू है, cos π/6 की वैल्यू है. तो इसकी सम ऑफ स्क्वायर ऑफ दिस टू नंबर 1 ही है, लेकिन इस एग्जाम्पल में वो प्रूफ करके बताने की ज़रूरत नहीं. वाई इट इज़ नॉट एसेंशियल? बिकॉज √3/2 इज द वैल्यू ऑफ व्हाट? cos pi by 6, cos 30. So directly we are able to replace it by cos 30, means cos pi by 6. In the same way, 1/2 is the value of what? Sin pi by 6, sin 30. So directly we are replacing it by what? Sin. अगर ये नंबर हमारे टेबल में नहीं आते थे, कौन सा टेबल? वैल्यूज ऑफ ट्रिग्नोमेट्रिक फंक्शन फॉर 0 डिग्री, 30 डिग्री, 45. At that time we have to prove that sum of square of these two number is 1, and that's why we are able to denote it either by sin, one number by sin and another number by what? Cos. That method we have seen in last example. लेकिन यहाँ पे coincidentally ये नंबर क्या है? 30 डिग्री का वैल्यू है cos 30 डिग्री का, और ये नंबर क्या है? sin 30 डिग्री की वैल्यू है. So replace it by cos 30 and second number by sin 30. So which is equal to cos inverse, keep it as it is. Now this expression is in the form of what? Cos A into cos B minus sin A into sin B, which is nothing but formula of cos A plus B. A is x and B is what here? Pi by 6. So which is equal to, now here cos inverse and cos will get cancelled. What is remaining term? X plus pi by 6, which is nothing but value of y. Now this expression is in the simplest form. So now we are differentiating it with respect to x. So differentiate with respect to x. Derivative of y with respect to x is dy upon dx. Derivative of x will be equals to 1 and derivative of pi by 6 will be equals to 0, because pi by 6 is a constant term. So in short we can say that value of derivative will be equal to 1 plus 0 means will be equals to 1. In this way we have got the derivative of this function. So now see the example number 3rd. Again we are using same method here. Keep sin inverse as it is. Since sin inverse is there in this function, that's why we are trying to convert this expression also in terms of sin. So cos root x, keep it as it is. So what is the numerical value here? 1 by √2 plus again sin root x, keep it as it is. Just simply I am dividing by √2 to both the terms separately. Here also divided by √2, isn't it? So here we can observe that √2 is nothing but value of what? Cos 45 also and sin 45 also. But here what is their sin inverse? Means our expression should be in the form of sin A into cos B. यानी ये cos होना चाहिए. ये अगर cos है तो ये cos A into sin B. ये sin होना चाहिए. तो let us denote it by sin and this by what? Cos. Means here cos root x, keep it as it is. Cos root x as it is. 1 by √2 can be replaced by sin 45. 45 means what? Pi by 4. Plus sin root x, keep it as it is. Again here 1 by √2 can be replaced by cos 45 means cos pi by 4. So now expression is in the form of sin A into cos B plus cos A into sin B, which is nothing but value of what? Sin A plus B. So sin A means what here? Root x, and B means what here? Pi by 4. So plus pi by 4. Again if you observe here, this expression is in the form of sin A into cos B plus cos A into sin B, where A is nothing but root x and B is nothing but what? Pi by 4. Now we have converted it in terms of sin. So according to property of inverse trigonometric function, sin and sin inverse will get cancelled, and what is remaining term? Root x plus pi by 4. In this way we have simplified the given function. Now whatever may be the simplified form is there, so differentiate it with respect to x. So derivative of y with respect to x is dy upon dx, and what is derivative of root x? We know that derivative of root x is 1 upon 2 root x, and derivative of constant term will be equals to 0. So this implies that value of dy upon dx will be equals to 1 upon 2 root x. In this way we have got the differentiation of this given function. Now see the example number 4th. Here given function is in the form of y is equal to cos inverse is there. And since cos inverse is there, so let us simplify this expression to convert it in terms of what? Cos. So here cos inverse, keep it as it is. So cos inverse of x, keep it as it is. And here cos 3x also as it is. Observe what is coefficient? 3 by 5. Its coefficient is 3 by 5. Minus, then keep sin 3x as it is, sin 3x, and its coefficient is 4 by 5. So 4 by 5 into 4 by 5 means simply we are dividing to both the term. Here 5 is there. I am dividing to both the terms separately by what? 5, isn't it? Now let us check whether 3 by 5 and 4 by 5, their sum of square of these two numbers is 1 or not. In the last two example, whatever maybe the numerical values are there are the values of what, either sine 30 or sine 60. So that's why we are directly able to replace it by trigonometric function. But we know that 3 by 5 does not appear in the table of what, trigonometric functions of 0, 30, 45, 60, 90. That's why we have to prove that sum of square of these two number equal to 1. So here 3 by 5 square plus 4 by 5 square will be equals to, observe that denominator of both the term is square of 5 means 25, and here also 25. Since denominators are same, we are taking addition of numerator. So square of 3 is 9 and here square of 4 is what, 16, which is equal to 25 upon 25 will be equal to 1. So we have proved that sum of square of these two number is equal to 1. That's why we are able to denote first number by sign. If we are denoting first by sign, then denote second by cos, or denote first by cos, then denote second by what, sign. That is our choice. That depends on the nature of example. As it stand, cos inverse is there, so we have to convert this expression in terms of cos. And why we are able to denote it by sine and cos? Because we know that sine square theta plus cos square theta is also equals to what, 1. Means sum of square of sine and cos is 1 and sum of square of these two number is also 1. That's why we are able to denote them by sine and cos, because this two number satisfies the identity. Which identity? Sine square theta plus cos square theta is equal to 1. So to convert this expression in terms of cos, what is our formula? Cos A into cos B minus sin A into sin B will be equals to cos A plus B. तो हमें cos A into cos B, यानी ये नंबर को हमें cos से डिनोट करना पड़ेगा. So let us denote first number by cos. So let cos alpha is equal to 3 by 5 and sin alpha is equal to 4 by 5. So which implies that tan alpha is equal to sin upon cos means 4 by 5 divided by 3 by 5. So will be equals to 4 by 3, which implies that alpha is equal to tan inverse of 4 by 3. Here if you will observe, the value of alpha, term of x does not appear, means variable does not appear. That's why we can conclude that alpha is constant. This implies that alpha is constant. And why we are going to prove that it is constant? Because we know that derivative of constant term is 0. While differentiating alpha, at that time we have to use this result that derivative of constant term is 0. That's why we are going to prove that alpha is a constant. Now we are substituting all these values in our function. So what is our function? Y is equal to cos inverse of cos 3x into 3 by 5, but 3 by 5 we are denoting by cos alpha minus sin 3x into 4 by 5 I am denoting by sin alpha. So which is equals to cos inverse of cos A into cos B minus sin A into sin B is the value of cos A minus B. A is 3x and B is what here? Alpha. So which is equal to, cos A plus B. Cos A into cos B minus sin A into sin B is the formula of what? Cos A plus B. A is here 3x and B is here alpha. Now we have converted it in terms of cos. Now according to property of inverse trigonometric function, cos inverse and cos will get cancelled, and what is remaining term? 3x plus alpha is the value of y. Now we are differentiating it with respect to x, because already the value of y is in simplest form. After converting it in simplest form, remaining part is to find out all required differentiation. So derivative of y is dy upon dx, derivative of 3x will be 3 and derivative of alpha will be equals to 0, which implies that dy upon dx will be equals to what? 3 plus 0 is equal to 3. In this way we have got the differentiation of the given function. Now see the example number 5th. In this case, given function is y is equal to cos inverse of. Since cos inverse is there, so our aim is to convert this expression in terms of cos. So hope all of you got the method very well, because we have already solved 2-3 example. So here also we are solving this example using the same method. So cos inverse, keep it as it is. Here first write down the term of trigonometry, that is cos e raised to power x. Numerical value is 3 upon under root 13 plus, again here trigonometric function is sine e raised to power x. Keep it as it is. What is numerical value? 2 upon under root 13. Means in short, we are dividing to both the terms separately by what? Root 13. Later on, we have to prove that the sum of square of these two numbers will be equals to 1. So let us check whether sum of square of these two numbers is equal to 1 or not. 3 upon under root 13 square plus 2 upon under root 13 square will be equal to, here we can observe that denominator of first term is square of root 13 means 13, and denominator of second term is also square of root 13 means 13. Means we can say that denominator of both the terms are same. So simply we have to take the addition of numerator. What is numerator here? 3 square means 9, and here square of 2 means 4. So which is equal to 9 plus 4 is 13. 13 upon 13 will be equals to 1. So what we have proved here, sum of square of these two numbers is 1, means we are able to denote these number by sine theta and cos theta. Since we have to convert this expression in terms of cos, what is the formula related with cos? Cos A into cos B plus sin A into sin B, means we have to denote this number by cos. So let us denote the first number by cos. Cos alpha is equal to 3 upon root 13 and sin alpha is equal to 2 upon root 13. So this implies that tan alpha will be equals to, tan means sin upon cos means 2 upon root 13 divided by 3 upon root 13. Isn't it? So root 13 will get cancelled. Here we will get 2 by 3. 2 by 3 will be the value of what? Tan alpha, which implies that alpha will be equal to, take tan on this side, so it will become tan inverse of 2 by 3. Isn't it? So here we can observe that in the value of alpha, x does not appear, means variable does not appear. That's why we can say that alpha is constant. So this implies that alpha is constant. So we have proved that alpha is constant. This result we will require while finding differentiation. So first we are simplifying the given expression. So after substituting this value in y means what? Cos inverse of cos e raised to power x, cos e raised to power x into 3 by root 13 we are denoting by cos alpha, plus then what is the next term? Sin e raised to power x, keep it as it is, and 2 upon root 13 we are denoting by sin alpha. Isn't it? So which is equal to cos inverse, keep it as it is. Now we can observe that this expression is in the form of cos A into cos B plus sin A into sin B, which is nothing but formula of cos A minus B. What is A here? E raised to power x, minus B is what here? Alpha. So here cos inverse and cos will get cancelled. We will get e raised to power x minus alpha will be the value of y. Once the value of y is known to us, means we have converted y in the simplest form. So remaining part is just to find out differentiation. So differentiate it with respect to x. Derivative of y is dy upon dx, and on this side derivative of e raised to power x is e raised to power x, and derivative of constant term is 0. So we can say that dy upon dx will be equals to e raised to power x, which is nothing but our required derivative of this given function. Now see the last example from question number 8. In this case we have to find out differentiation of y is equal to cosec inverse of 10 upon 6 into sin 2 raised to power x minus 8 into cos 2 raised to power x. So here we are applying the properties of inverse trigonometric function. So cosec inverse can be converted in terms of sin inverse just by taking reciprocal of this term. Means if you are taking reciprocal of this term, so according to one of our property of inverse trigonometric function, cosec inverse will get converted into what? Sin inverse. So applying that property, we are converting it into sin inverse. To convert it into sin inverse, simply we have to take a reciprocal of this term. So what we will get here? 6 into sin 2 raised to power x minus 8 into cos 2 raised to power x divided by 10. Now once we have converted this example in terms of sin inverse, now remaining part is just to convert this expression in terms of sin, so that sin inverse and sin will get cancelled. So let us simplify this expression, keep this sin inverse as it is. Here first write down term of trigonometric function, that is sin 2 raised to power x into numerical value, that is 6 upon 10, minus then write down cos 2 raised to power x into 8 upon 10, Okay, so now we are trying to show that sum of square of these two numbers will be equals to 1. So here we can observe that 6 upon 10 square plus 8 upon 10 square. Easily we can observe that denominator of both the term is 10 square, means 100 denominators are same. So that's why we are taking addition of numerator. Here square of 6 is 36 and here square of 8 is 64, which is equal to 100 upon 100 is equal to 1. Once we have shown that sum of square of these two number is equal to 1, means one number we are able to denote it by sign and another number by what? Cos. So as it stands, we have to convert this expression in terms of sign. And what is the formula related with sign? Sin A into cos B minus cos A into sin B, means this number we have to denote it by cos. So here let cos alpha will be equals to 6 upon 10 and sin alpha will be equals to 8 upon 10. If we are taking their division, then it will implies that tan alpha will be equal to sin alpha, means 8 upon 10 divided by cos alpha, means 6 upon 10. 10 will get cancelled. What will get? 8 upon 6 will be equals to 4 by 3. Means it implies that value of alpha will be equal to tan inverse of 4 by 3. Here we can observe that in value of alpha, x does not appears. X is what? Variable. Variable does not appears, means we can say that value of alpha is constant. So this implies that alpha is constant. Once we have proved that alpha is constant, then consider the given function y is equal to sine inverse of sine 2 raised to power x into 6 by 10. 6 by 10 we are denoting by cos alpha minus cos 2 raised to power x into 8 by 10 we are denoting by what? Sin alpha. Once these values are substituted, observe this expression. It is in the form of sin A into cos B minus cos A into sin B, which is nothing but formula of sin A minus B. So sin inverse, keep it as it is. Here this is the value of sin A. A means 2 raised to power x minus B. B means what? Alpha here. Now applying property of inverse trigonometric function, here sin inverse and sin will get cancelled. What is remaining term? 2 raised to power x minus alpha. This is the value of what? Y. Once the value of y in simplest form is known to us, differentiate it with respect to x. So differentiate it with respect to x. Derivative of y is dy upon dx and derivative of 2 raised to power x is 2 raised to power x into log 2, because it is in the form of a raised to power x, and we know that derivative of a raised to power x is a raised to power x into log a, where a is nothing but here 2, and derivative of this constant term will be equal to 0. Why we are saying that alpha is 0, alpha is constant? Already we have proved that alpha is constant, and that's why we can say that its derivative will be equal to what? 0. So this implies that dy upon dx will be equals to 2 raised to power x into log 2. This is nothing but our required derivative. In this way, we have completed all the example from question number 8. So if you think that these videos are helpful to you, so please like the video and share these videos with your friends. In the next video, we are starting question number 9th from this exercise.